This is problem 9 of chapter 15 from the textbook Stats Modeling the World by the authors BVD. So for this problem we're going to look at a deck of cards and we're going to answer some probability questions that are called a particular type called conditional probability. So before we dive in, let's just take a look at a deck of cards in case you're not familiar. There's a total of 52 cards, and they're broken up into sort of 4 categories, or what we call suits: clubs, spades, diamonds, and hearts. And it turns out that the clubs and the spades are black cards, and the diamonds and hearts are red. And then each category or suit has 13 cards, 2 through 10, and then a jack, queen, king, and ace. Okay, so that's what we're working with. That's our population. And then the other thing I want to review real quickly is we have some kind of like a formula for a straightforward conditional probability. We say that the probability of A given B is equal to the probability of A and B divided by the probability of B. Now, that I've always found to be a little bit hard to remember, especially when I was learning probability for the first time. So I came up with a slightly different way of thinking of it. If you can read this, the probability A given B, then this would be the probability of both happening divided by the probability of the given. The conditional probability basically reduces the whole to a smaller part, so to speak. So anyway, the probability of both divided by the probability of the given. So let's see if we can apply these. Okay, so we want to know the probability of a heart given that it's red. So we could write the probability of heart given that it's red. And then if we use our formula, let's see, that would be the probability of both, so the probability of a heart and red divided by the probability of the given, which is red. Okay, so now the probability of a heart and red, let's think about this. Well, if it's a heart, then if there's red, there's 26, but if it's a heart, there's 13. So there would be 13 out of 52. That would be on the top. And then we would divide that by the probability of red. So there's 26 red cards. So 26 divided by 52. And I'm going to be a little bit formal. So we turn that into multiplication, right? We would flip this, 52 over 26. And then these cancel. So we get 13 out of 26. And that can be simplified to 1/2. Okay, so that's how you do the answer to the first question. Okay, so let's look at another one. What's the probability the card is red given it's a heart? Well, let's just go ahead and write out the formula. It's the probability of red and heart. So I believe that's going to be very similar, divided by the probability of the given, which is a heart. Well, probability of red and heart, we already know that that's 13 out of 52. And we're going to divide that by the probability of a heart. Well, the probability of a heart, there's 13 hearts, right? There's 13 hearts. So 13 out of 52. So then that's 13 out of 52 times 52 over 13, a little bit of algebra. And so these cancel, and we get 1 and a 1. These cancel, and we get a 1 and a 1. So it looks like we get 1 divided by 1, or 1. Okay, so that's 100%. So does that make sense? If I said I have a card and it's a heart, then what's the probability it's red? So logically, you can think through it. But here is how we write it out. Okay, let's look at another one. The probability of an ace given it is red. Well, that's the probability of an ace and red divided by the probability that it's red. Okay, so the probability of ace and red, well, there's 2 red suits, diamonds and hearts, and each have an ace. So there would be 2 out of 52. That would be 2 out of 52 divided by the probability of red. So there's 26 red cards. Half the cards are red, so 26 out of 52. So 2 over 52 times 52 over 26. So that's 2 over 26, 26, getting ahead of myself, or 1 out of 13. And I think that when I did it, double check, so about 7.7%. Okay, last one. Hopefully you're getting the hang of it. But anytime you see the word given, it's kind of given away, so to speak. So probability of a queen given, it's a face card. Ooh, interesting. Face card. Okay, so let's just go slow. The probability of a queen and a face card divided by the probability of a face card. Oops. Probability of a face. Okay, so it's a queen and it's a face card. Well, there's 4 queens, right? There's 4 queens. So I think that's 4 out of, why did I write 42? 4 out of 52 divided by, now the probability of a face card, let's check this out. There's a jack, queen, king. Those are face cards. Oops. Yeah, those are face cards. Sorry. I'm panicking. 1, 2, 3. So, but there's 4 suits, so that would be 12. So there's a total of 12. So the probability of a face would be 12 out of 52. So 4 out of 12. Let's see. If we were doing algebra, so that would be 1/3, or 0.333, or if you wanted 33.3%. Okay, so this is your basic way of dealing with conditional probability. Just try to remember, whenever you see a given, then think of this formula, and it should work itself out. Okay, good luck.